All right, so our 5.5 notes, we're moving on to some inequalities in triangles. Obviously, my voice is not 100% back yet, so bear with me. Um, Sadly for me, I'm going to have to redo the video for next year, later on when my voice comes back. But, all right, so we're going to talk about some angle-side relationships in triangles. First one triangle and then later on in two triangles. So if you take a look at the first theorem, what it says is that if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. Now, what does that mean? Let's call this triangle ABC. All right. And if we know that any two sides are not congruent, we're talking about a scalene triangle. So regardless what we have, this works only if we have a scalene triangle here. And it's saying that if I know information about two sides, then I also know information about two angles. So for example, if I know that AB, that measure is greater than BC, that also tells me the angles opposite those sides share a relationship as well. So what do I mean by angle opposite the side? Well, AB, this red side, is does not touch C, so it's opposite angle C. All right, so the measure of angle C is related to AB. Okay, now what would be opposite BC? Hopefully you're seeing the angle opposite BC is angle A. Now, remember, the theorem says that the larger angle is opposite the longer side, so go longer and larger. AB is the longer side, so angle C must be the larger angle. All right, so that's the first theorem. The second theorem is the of the first theorem. So now we're going to say, what if I'm given information about angles? How does that help me with the sides? All right, so that was the first theorem. So I scroll down a bit so you can see the second theorem, which again I said was just the converse. So you want to write that down, right? If two, excuse me, angles in a triangle are not congruent. So again, basically telling us we've got a scalene triangle, because two angles would be congruent if we have isosceles, and three angles would be congruent if we have equilateral. But again, if two angles are not congruent, then the longer side is opposite the longer angle of the larger angle. So again, let's take a look at the diagram. We've got triangle XYZ here, and what I have, here is now I'm going to be given information about angles instead of sides. So, for example, if I knew that the measure of angle Z is greater than the measure of angle X, then I can conclude that the sides opposite those angles, so if you look across from angle Z is the side XY, and across from angle X is the side ZY, right? So then what I can conclude is that the larger angle corresponds with the longer side. So since angle Z is the larger angle, XY should be longer than ZY. And that's your second theorem. All right? So scroll up just a little bit here. So one of the things I could ask you to do is I could ask you to just list out the angles or the sides in order from smallest to biggest or shortest to longest. So remember, excuse me, for example, 1A, the longest side is always across from the largest angle. So if you look at example 1A, hopefully you're seeing the smallest side here is GH, right? That is less than GF, which is less than FH, right? So we see it in this order. So then the angles should also correspond, but now just make sure you know which side is across from which angle. So GH, this side here, is across from the angle F, right? So that is the measure of angle F, all right? So the measure of angle F is across from the shortest side. Then GF is across from which angle? Well, that should be angle H. And I realized I don't actually need to write measurements here because we're just looking at listing the angles. I'm sorry, my dog is reacting to a truck outside. Let's see if she quiets down. Be quiet? I guess not. So let me pause and let her bark it out. Alright, I think she's all barked out. So let's continue. So again, angle F was across from GH, and since GH is the shortest side, angle F is the smallest angle. And I'm doing this because the direction set smallest to largest. Oops, there she goes again. Alright, so then that middle side, GF, is across from angle H. So I'm going to list angle H next. And then finally, the largest side, the longest side was FH, and that's across from angle G. So there's example 1A, okay? Example 1B, same deal, but now we want to write these sides in order from shortest to longest. So what could be helpful here is getting that third angle. Now remember, all three angles in a triangle add up to what number? Of course, it should be 180 degrees. So let's do that first. Let's find the measure of angle R. So I know 72 plus 60 plus the measure of angle R should add up to 180 degrees. And then I can just do my algebra, right? To find out that the measure of angle R is equal to, excuse me, 48 degrees. So that makes angle R the smallest angle. So then if I list my angles out from smallest to biggest, I got, well, I don't need to write measurement again. So again, just listing out the angles from smallest to biggest, it's angle R, then it'll be angle P, and then angle Q. And then you want to go ahead and pick the sides that are opposite each angle. So the side opposite of angle R should be the side PQ. So I'm going to list PQ first. Okay. Then angle P goes across from the side QR. And, oh, kind of touching things all over the place here. Let's back up. There you go. So angle P is across from QR, and then angle Q is across from the side PR. And there's my answer to example 1B. All right. Now we can also have what we call the triangle inequality theorem. And this is actually really, really great if you're trying to decide if you can construct a triangle. Okay, so the triangle inequality theorem, again, just basically tells you if you can create a triangle. So the sum of any two side lengths of a triangle has to be greater than the third side. Otherwise, the triangle won't close, and you won't have a closed shape, which doesn't make the triangle work. So basically, you've got three inequalities you can write. So any two sides, for example, AB plus BC, that sum has to be greater than that third side, AC. Okay? And again, I can move around those sides in any combination I want. So I can also say, well, that also means AB plus AC, that should be greater than BC. But finally, that third combination also needs to work, where AC plus BC has got to be greater than AB. And that is the triangle inequality theorem. And you're going to have problems like example 2, where I'm going to ask you to decide whether or not we can't have a triangle with those side lengths. So again, the first thing I like to do is I like to set up the problem. So I've got, excuse me, 3 inequalities I have to check. They all must work for the triangle to be able to be drawn. So we can't just have 2 out of the 3 work or 1 of the 3 work. It has to be all 3 or nothing. Okay, so set up your inequalities. So I know 7 plus 10's got to be greater than 19. 7 plus 19 has got to be greater than 10. And finally, 10 plus 19 needs to be greater than 7. And remember, the moment one of these doesn't work, so for example here, you guys can probably already see this. 17 is greater than 19. No, not true. So when that happens, then we're going to say, no, a triangle cannot have these given side lengths. And let me move this up because I think there's one of those logos in the corner, right? So that's how we can deal with something with these numbers that are given, right? I'm going to slide this over so you can see B. B, same deal. Now I'm just telling you n is 4, so you've got one extra step. Plug in n, right? So if n is 4, this is 10. If n is 4, this is 15. If n is 4, this is 12. And once again, you've got 1, 2, 3 numbers, and 3 inequalities we're going to check. So 10 plus 15 needs to be greater than 12, right? 10 plus 12 should be greater than 15. And finally, 15 plus 12 needs to be greater than 10, right? And just check if all three work. If one doesn't work, stop right there and say no. So we've got 25 is greater than 12. Awesome. 22 is greater than 15. Awesome. 27 greater than 10. Definitely true. So yes, a triangle can have these lengths. Okay? So let's do one more example, and then we'll stop here and we'll do indirect proofs in class. So let me pause and just resize my window for a moment. All right, last example. So now what if I'm only giving you two sides and you've got to figure out, well, what could that third side possibly be? Well, there's more than one answer to that because there's so many different ways you can combine two legs of a triangle. The key thing is two sides should add up to a number greater than that third side. So let's call this third side some variable. We can call this x. All right. So we basically got two numbers, 8, 13, and an unknown x. Still got to set up three inequalities. So 8 plus 13 is greater than x, right? 8 plus x needs to be greater than 13. And finally, 13 plus x is greater than 8. Solve all three. So 8 plus 13 is 21. Okay. Subtracting 8 from both sides. X is greater than 5. And then here subtracting 13 from both sides. X is greater than negative 5. So I want you to combine this into a compound inequality. So there's really one that we can cross off because we know our lengths must always be what kind of numbers? They need to be positive. So of course x is going to be greater than negative 5. That's a given. So we're going to combine these two together to create our range. So 5 is the lower end and 21 is the higher end. So x is somewhere, oops, sorry, I meant to write 21. So x is somewhere between those two numbers. So we can have a triangle with lengths 8, 13, and 12. We can have 8, 13, and 5.2, right? We have 8, 13, and 20.9, anywhere between 5 and 21. All right? So that is it for the notes today. We're going to do indirect proofs in class, so look forward to that. Come back with questions, especially if you couldn't understand what I was saying.